Hello, I'm Ali Kani, Vice President and General Manager of NVIDIA's Automotive Business. It's a pleasure to be here today at IAA Mobility 2021. AI is the most powerful technology force of our time, and it's transforming virtually every industry from healthcare, finance, to energy and manufacturing. The breakthroughs in AI are nothing short of science fiction, and nowhere is this transformation more significant than in the automotive industry. Autonomous driving is perhaps the most intense AI challenge, but it's also the one with the greatest impact to society. It will save lives, make roads less congested, and change the way billions of people move around the world. Transportation is a $10 trillion industry. It includes not just passenger vehicles, but also commercial trucks, robo-taxis, delivery vans, and even specialized vehicles used in agriculture, construction, and mining. In the past, passenger vehicles were defined by their driving experience. A key capability of a vehicle was its horsepower. But now, advancements in deep learning and robotics technologies are redefining the auto industry based on a vehicle's computing power. Eventually, everything that moves will be automated, but it will take time and a significant investment to get there. The mission of the NVIDIA Drive team is to develop the self-driving platform and software stack to enable our partners to bring it to market. These future cars and trucks are going to be completely programmable computers. Business models for the transportation industry will be software-driven. This tech mindset will fundamentally see a car not as just hardware sold, but as an installed base where the entire fleet gets new services over the life of a car. I want to start by explaining how challenging it is to develop self-driving cars. First, you need a high-performance computer architecture and sensor suite in every car that's capable of delivering a safe self-driving experience. A self-driving fleet will generate many petabytes of data each day, all of which needs to be encoded, secured, and then sent to the cloud. This data then needs to be labeled to identify every object, lane marking, and traffic sign. And after all of this data is processed, we need to train the deep neural networks on a dataset. These AI models are then tested on a full range of scenarios in a digital twin of the real car using simulation to allow for the testing of rare and difficult driving situations in a scalable and efficient manner. Finally, we need to test autonomous driving software in the production test fleet to ensure our autonomous vehicles are safe. This entire process is never ending. Autonomous driving software will need to be continuously developed and improved. NVIDIA is building our AV platform end-to-end with the highest functional safety and cybersecurity standards. From the AV chips and computers, sensor architecture, data processing, AV perception, mapping, and cockpit software, to the infrastructure where we train and create a simulated digital twin, onto the fleet command and operation center where you can remotely operate your fleet, and finally road testing. And we're creating this platform in modules so that our partners can use exactly what they need. Since AV is such a grand challenge and will take years to develop, we believe what differentiates AV excellence more than anything else is the speed of this development flow. The companies with the best development flow will be the most successful AV companies. AI-powered vehicles will get smarter and smarter over time as the software is trained with more data for new tasks, tested and validated, and then finally updated over the air into each vehicle. Developing an autonomous vehicle requires an entirely new hardware platform architecture and software development process. Both the hardware and software must be comprehensively tested and validated to ensure they can handle the harsh conditions of daily driving with the stringent safety and security needs of an automated vehicle. Now that's why NVIDIA has built and made open the Drive Hyperion platform that specifies a computer and sensor architecture that meets the safety requirements of a fully autonomous vehicle. Hyperion is designed with redundant drive-oriented computers and state-of-the-art surround cameras, radar, and LiDAR. It's architected to be functionally safe, so that if one computer or sensor fails, there's a backup available to ensure that the autonomous vehicle can drive its passenger to a safe place. We're making Hyperion to help our partners who want to build self-driving software themselves. We have spent many years developing a data collection system with high-quality calibration and time synchronization in 3D so our partners can leverage NVIDIA's base platform investment so they can focus their resources on their AI application development. And since AV is such a grand challenge, we have also defined Hyperion with a standard computer form factor so that customers can design their autonomous vehicle to scale across generations of their vehicles. With this standard form factor, a customer can go to production with a drive Orin computer today and easily plug in a hardware and software compatible drive Atlan computer in the future. Infrastructure services and tools are the keys for developing an efficient self-driving platform. Autonomous driving software development process requires several infinite data loops to work together. These loops are designed to train your AI models, simulate your AV software, and then to drive. AV software also needs to remember your driven routes, otherwise known as drive mapping, and then learn again. So there's a ton of data, and they're in loops. AI model training loops, simulation loops, mapping loops. And each of these loops are all running continuously, and they're all interlinked. This is not easy to bootstrap, and it's not easy to operate. However, this is what it's going to take to run a self-driving system that's safe. And while it might sound a bit complicated, it's very sensible. In a sense, this pipeline is what AI software development is all about. It's a data model, processing-driven approach to computer science. This way of developing software is profoundly different from the way software was developed in the past. It requires supercomputers in the data center and supercomputers in the car. This end-to-end data factory is the essence of NVIDIA's self-driving car initiative. At NVIDIA, we're building a world-class AV stack that can scale to the most complex scenarios. Perception is one of the most important and compute-intensive parts of any AV stack. We've built nearly 20 perception models to help you see cars, bicyclists, and pedestrians. We've designed networks to classify lanes, signs, lights, parking spots, and road boundaries. Our perception software is designed to be functionally safe, as we've designed multiple neural networks to see a given object, and we perceive objects on different sensors. We design our system with this resiliency such that no single sensor or AI model becomes a single point of failure. When you have great perception software, you can perceive lanes, signs, poles, and lights, which can help you build a high-quality driving map. This generated high-definition map is also kept fresh because an AV is always learning. Drive AV dynamically updates maps after any vehicle in an OEM's fleet drives the same route again. As part of our commitment to expanding our mapping capabilities, we recently announced our acquisition of DeepMap. As a leader in scalable HD mapping, DeepMap will improve and accelerate the international scale of NVIDIA's Drive AV platform. NVIDIA is building a best-in-class autopilot product. We want to provide a great address-to-address experience for our customers, with continuous expansion in coverage of scenarios and ODDs driven by data and enabled seamlessly with over-the-air updates. Such a product needs to be able to handle dangerous situations and complex maneuvers, which we are already actively developing and in many cases already testing. This includes handling controlled and uncontrolled intersections, busy crosswalks, roundabouts, along with addressing vulnerable road users like bicyclists. A validation strategy is critical to make sure AV is safe. Autonomous vehicles must be able to respond properly to incredibly diverse situations on the road: emergency vehicles, unpredictable pedestrians, congested traffic, and even poor weather conditions. There are an infinite number of scenarios that are very rare to come across in the real world. While we need to test an AV on the road, it's really hard to experience all these corner case situations that happen in the real world. This is why it's critical to also test AV in simulation, and why NVIDIA has built our own simulation platform based on Omniverse. It's called DriveSim, and we use it for HD map reconstruction, synthetic data generation, new scenario simulation, and replay validation. Only with a combination of on-road testing and simulated testing can you really make sure an AV vehicle is ready to safely drive. Now let me show you what DriveSim software lets you do in this video. Over the last year, we've made several significant announcements with key auto and truck makers. This video shows you the early results of our collaboration with Mercedes-Benz, which starts with a development flow that lets you first develop AV software in a physically accurate simulator that's essentially identical to a real car. In this video, we have modeled the Mercedes-Benz EQS to be true to life. This includes accurate vehicle shape and dimensions, along with real dynamics based on a vehicle's tires and transmission so that the acceleration, braking, and cornering are accurate. We have completely modeled the sensor suite. We are running AV on an identical computer architecture in the cloud. After building the virtual car, we're able to run AV software running in a digital twin of the real vehicle. With DriveSim, we can run different traffic and weather models to test the robustness of our AV software, as this car computer doesn't know it's running on a virtual world in the data center. We're extremely proud of this accomplishment, as we're able to get AV software running on a new sensor suite and car within just a few months. By having a physically accurate drive simulator, you can accelerate development efforts by letting developers first test in simulation and then test in the real world. I'm really excited and proud of the size of NVIDIA's Drive ecosystem, which includes hundreds of companies developing on our Drive platform. They encompass automakers, truck makers, Tier 1 suppliers, software startups, sensor makers, mapping companies, and more from around the globe. All are looking to bring safer, smarter transportation to our roads. Some are building software that can get deployed on OEM vehicles, while others are OEMs building Level 2 cars, Level 4 commercial trucks, and even Level 5 robotaxis. We've built our platform to be modular so customers can build the best product that fits their needs and requirements. And we're the only company today that has an open platform for the industry to build on. Thank you for joining me today during IAA Mobility. I hope I've been able to provide you with a deeper understanding of how NVIDIA is developing the core technologies fundamental to the development and deployment of self-driving cars to enable a safer travel and extend the freedom of mobility to all.